What makes a tree fall in a particular direction? How can people change this direction? To control a tree's fall, one must harness physics and use it to their advantage. When cutting a tree down, there are several factors to keep in mind. The first of these factors is tree lean. When a tree is leaning in a particular direction, gravity will naturally want to pull it in that direction because the center of gravity is no longer above the stump. The center of gravity is the point where the pull of gravity all around it equalizes. Simplified, if the tree were a single stick, the center of gravity is the point on which the stick will balance. Move the stick to one side, and the stick will fall to the side with the center of gravity. Tree felling manipulates the location of the center of gravity to have the tree fall in a desired direction. Notch direction is another factor. A notch helps guide the tree. It harnesses gravity's force to manipulate fall direction. The notch works with the hinge. A hinge is a band of fibers behind the notch that acts like a hinge to help guide the tree. It is the pivot point of the tree as it falls. It is one of many simple machines at work in tree felling. Very often, a tree's lean is not in the intended direction of fall. If the center of gravity is not over the notch, gravity will not produce enough torque to pull the tree in the intended direction. In this case, force needs to be applied in one of many ways. They all work in different ways to achieve a similar result. Moving a tree's center of gravity across the hinge, overcoming the unwanted force of gravity so that the notch and hinge can guide the tree to the desired drop zone. Wedges can be inserted into the back cut. Wedges lift the back of the tree to move the center of gravity. As they are hammered in, the taper of the wedge forces the cut to expand. Since the stump is stable, the only way for the cut to expand is for the back of the tree to lift up. The wedges are responsible for creating enough torque so that the entire tree rotates around the hinge until the center of gravity is above the notch and gravity can take over producing the torque necessary to bring the tree to the ground. A felling lever works on a similar principle. It lifts the back of the tree, creating torque to achieve the same goal as a wedge. It is also inserted into the back cut, but it has a long handle for leverage and the head acts as the fulcrum. The exact part of the head depends on whether the handle is pushed or pulled. If it is pulled up, the fulcrum is the tip. If it is pushed down, the fulcrum is where the head meets the handle at an angle. With the felling lever, torque is involved in several places. The felling lever rotates around the fulcrum. The longer the handle, the more force is applied to the tree, because the farther from a pivot point a force is applied, the greater the torque. Just like with wedges, torque is applied to the tree to rotate it about the hinge. Ropes can also be used to pull the tree over, often with mechanical advantage from pulleys. Each pulley used doubles a person's pulling power. When used in series, they can significantly help somebody pull several times their body weight. Many systems used to pull trees over use 4 pulleys, making a 5-to-1 mechanical advantage. With this ratio, for each newton someone pulls on the tail of the rope, 5 newtons are applied to the tree. When somebody pulls just a fifth of the force keeping the tree leaning backwards, the mechanical advantage is enough to overcome it. Ropes create torque from the top of the tree, rather than at the base, to move the center of gravity in relation to the hinge and notch. Here, the length of the tree from the hinge to the point where the rope applies force to the tree acts as a lever. The higher the rope is in a tree, the longer the lever is, creating more torque. Through the use of simple machines, large trees can be manipulated to overcome the natural forces they are normally subject